Good morning, students. So let us continue with the nuclei topic. Okay, so
Good morning, ma'am.
today we are discussing with the nuclear forces. So yesterday we have seen what do you mean by nuclei, what are the different definitions, the composition of the nucleus, the different terms like atomic number, mass number, the radius of the nucleus. Yes, so these all points yesterday we have discussed. So today we are discussing with the nuclear forces. So what do you mean by nuclear force? Let us see. Yes. So yesterday I told you about the nucleons. So what do you mean? Anybody remember? Nucleons. What do you mean by nucleons? So as you know that the nucleus consists of the protons and the neutrons, So this protons and neutrons together, it is called as what? Nucleons. It is called as what? Nucleons. Yes, the protons and the neutrons together, it is called as the nucleons. So whatever these nucleons are bounded by the nucleus, so the force required for that, that is called as what? That is nuclear forces. So how we can define the nuclear forces? The nuclear force is defined as, that is, it is the force that holds the nucleons together with the nucleus is called as the nuclear forces. Here you can see these are the strong attractive forces which hold protons and neutrons together in a tiny nucleus is called as what? Nuclear forces. Hope so it is clear to you. Suppose if you consider this as an atom and the central part is called as the nucleus, and the nucleus consists of protons plus neutrons. So to hold this protons plus neutrons with the nucleus, whatever the force is required. So something if you are holding in the sense, there must be some forces acting. So here to hold these nucleons with the nucleus, whatever the forces required, the force is called as what? Nuclear forces. Yes. Hope so the nuclear force is clear to you. Here we have some of the definitions of the nuclear forces. Not some of the properties of the nuclear forces. You can say properties or you can say the characteristics of the nuclear forces. So the nuclear forces, the first property is it is a strong attractive force. So here you can say that the nuclear force is it is a strongly attractive force. So it is not a repulsive force, it is only a attractive force. So we have two types of forces, attractive and the repulsive forces. Adralli nuclear force annodeniದೆ, it is a attractive force. Okay, so suppose if you consider the gravitational force is also a attractive force. Okay, so suppose if you consider the Coulomb force, ನೀವೀಗ different forces ಅನ್ನ ಕಲ್ತಿದ್ದೀರಾ, ಅದ್ರಲ್ಲಿ ನೀವೇನಾದ್ರೂ Coulomb force ಅನ್ನು consider ಮಾಡಿದ್ರೆ, it is between the charges. So it is attractive also, it is repulsive also. Suppose if you consider the magnetic force, it is again attractive as well as repulsive force. Okay, but here the nuclear forces, it is only an attractive force. So we can say that it is strongly attractive force. So we can say the nuclear forces strongly attractive force. It is strongly attractive force. What about the second one? So the second point or the second property is it is the strongest force in the nature. It is the strongest force in the nature. So here we have four fundamental forces in the nature. Anybody remember what are the four fundamental forces?
Frictional
Yes, in first
force.
year. Which one?
Frictional force.
Frictional force, it is there, but it does not come under fundamental force. Fundamental force andre basic forces. Four are there, see. So the
Strong
fundamental force, one is the
gravitational force.
gravitational force. Second one is a electrostatic force, or sometimes they consider it as electromagnetic force also. So electromagnetic force, strong nuclear force, and the weak nuclear force. So these are the four fundamental forces in the nature. So that is the gravitational force, the electromagnetic force, strong nuclear force, and the weak nuclear force. Okay. So among these four fundamental forces, the gravitational force is called as the weakest force in the nature. So weakest force andre yav barutte, the gravitational force is the weakest force in the nature, and the strongest force among these four fundamental forces is that is strong nuclear force. So therefore, ಇಲ್ಲಿ ನಾವೇನ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದೀವಿ, that is, it is the strongest force in the nature. So the nuclear force is the strongest force in the nature. Okay, the third property regarding the nuclear forces, it is extremely short range force. So nuclear force ಅನ್ನೋದೇನಿದೆ, it is the short range force. It is the short range force. Okay. So next property regarding the nuclear force, it is strongly attractive force. It is the strongest force in the nature. It is short range force. The next property regarding nuclear forces, that is, it is a short range forces over. It is charge independent. It is charge independent. Okay, so first I'll tell you all the four characters, then I'll tell you explanation of this. It is charge independent, and the next one is, it is non-central force. It is non-central force. The next one is, it is a saturated force. It is a saturated force. The next one is, it do not obey inverse square law. So ಇದೇನ್ ಮಾಡಲ್ಲ, inverse square law obey ಮಾಡಲ್ಲ. It does not obey the inverse square law. The next property is exchange force. It is also called as the exchange force. And one more is, it is spin dependent. It is the spin dependent force. Okay, so here you can see these are the characteristics of the nuclear force. It is the strongest attractive force. Sorry, it is the strongly attractive in nature. Then next, it is the strongest force in the nature. It is the short range force. It is non-central force. It is saturated force. It does not obey inverse square law. It is also called as the exchange force. The next, it is charge independent and spin dependent. Yes, see, total we have 6 plus 3, that is 9 force, 9 properties or the characteristics are there for the nuclear forces. See, okay, so here we say that it is a very short range force. So here the nuclear forces come into play within the small distance. Andre nuclear force ಅನ್ನೋದೇನಿದೆ, this is only applicable for the nucleus, right? So nucleus ಒಳಗಡೆ protons ಮತ್ತೆ neutrons ಇರುತ್ತೆ. It is only applicable within the nucleus. ಹಾಗಾಗಿ ಇದನ್ನ ಏನಂತ ಹೇಳ್ತಾರೆ students, ಇದನ್ನ short range force ಅಂತ ಹೇಳ್ತೀವಿ. So why it is called as the short range force? Because it is applicable only within the nucleus. ಹೌದಾ, nucleus ಹೊರಗಡೆ ನಮ್ಗೆಲ್ಲೂ nuclear force ನೋಡ್ಲಿಕ್ಕೆ ಸಿಗಲ್ಲ. So therefore here it is a short range force ಅಂತ ಹೇಳ್ಬೋದು. The next one is, that is charge independent ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. That is the force between the nucleons, that is proton proton ಆಯ್ತು, neutron neutron ಆಯ್ತು, ಅಥವಾ proton neutron is found to be same. ಹೌದಾ, ಯಾಕಂತಂದ್ರೆ because here you see whatever the force is there, here proton is positively charged. Proton ಅನ್ನೋದೇನಿದೆ, it is positively charged. But what about the neutron here, students? Yes, neutron positive ide, negative ide. Yes, what about the neutron? These are neutral in nature. ಹೌದಾ, so ಇದೇನಿದೆ neutrons ಅನ್ನೋದು, it is neutral in nature. It does not have either positive charge or the negative charge. It is neutral in nature. Therefore here the force between proton neutron ಇರ್ಲಿ, between proton ಇರ್ಲಿ, ಅಥವಾ neutron ಇರ್ಲಿ, it is same. So ಯಾವ್ದ್ರ ಮಧ್ಯೆ ತಗೊಂಡ್ರು ಕೂಡ ಸೇಮ್ ಇರುತ್ತೆ, because ಇದ್ರಲ್ಲಿ ಒಂದ್ ಮಾತ್ರ ಚಾರ್ಜ್ ಇದೆ, another one is not having any charge. So therefore we call it as what? Charge independent ಅಂತ ಹೇಳ್ತೀವಿ. It is called as the non-central force here, students. So central force ಅಂದ್ರೆ ಏನು ನೋಡಿ, suppose gravitational force ಅನ್ನ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, it is called as a central force. ಯಾಕೆ ಹೇಳಿ? Because suppose this is one body having mass m1, this is the other body having mass m2. So suppose these are the centers of these two bodies. So the gravitational force acts along the center of these two bodies. So gravitational force ಅನ್ನೋದೇನಿದೆ, it acts along the center of the bodies. So therefore here it is called as what? Central force. But nuclear force ಅನ್ನ ಏನಂತ ಕರೀತಾ ಇದ್ದಾರೆ? ನಾನ್ ಸೆಂಟ್ರಲ್ ಫೋರ್ಸ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ನಾನ್ ಸೆಂಟ್ರಲ್ ಫೋರ್ಸ್ ಅಂತಂದ್ರೆ, ಸೊ ಅಲಾಂಗ್ ದ ಸೆಂಟರ್ ಆಫ್ ದ ಬಾಡೀಸ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರಲ್ಲ. ಸೊ those forces are called as what? Non central forces. Yes, So central force, along the center, the force acts. Non-central force, it is not acting along the center of the bodies. That is called as the non-central forces. Okay. Next, it is saturated anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ. What is the meaning of saturated here? Here each nucleons exert a force only on its nearest neighbors. So ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ, whatever the forces are acting very close to the next neighboring body. So therefore it is called as what? Saturated. Okay. It does not obey the inverse square law. So what is inverse square law? ಯಾವುದೇ ಬಾಡಿ ಮಧ್ಯ ಫೋರ್ಸ್ ಇರೋದು ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಸ್ಕ್ವೇರ್ ಆಫ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಇದ್ರೆ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ obeys inverse square law. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ಫಾರ್ ದ ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸಸ್ ಇಟ್ ಡಸ್ ನಾಟ್ obey. ಸೊ ಸಪೋಸ್ ನೀವು ಕೂಲಂಬ್ ಫೋರ್ಸ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಏನ್ ಹೇಳ್ತೀರಾ? ದ ಫೋರ್ಸ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದ ಚಾರ್ಜಸ್ ಅಂಡ್ ಇಟ್ ಇಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಸ್ಕ್ವೇರ್ ಆಫ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್. ಎಸ್, ಸೊ ದಿಸ್ ಇಸ್ inverse square law which is obeyed by the Coulomb force. And if you go for the new gravitational force al kuda enagutte, the force is directly proportional to product of the masses, inversely proportional to square of the distance between them. So again here it obeys the inverse square law. But nuclear forces alli illen proton aitu, proton neutron aitu, ಅಥವಾ proton ನ್ಯೂಟ್ರಾನ್ ಮಧ್ಯೆ ಏನ್ ಫೋರ್ಸ್ ಇದೆ, ದಟ್ ಇಸ್ ನಾಟ್ ಡೈರೆಕ್ಟ್ಲಿ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಸ್ಕ್ವೇರ್ ಆಫ್ ದ ಡಿಸ್ಟೆನ್ಸ್. ಹಾಗಾಗಿ ಇದನ್ನ ಏನಂತ ಹೇಳ್ತಾರೆ? ಇಟ್ ಡಸ್ ನಾಟ್ ಒಬೇ ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಲಾ. ಇಟ್ ಡಸ್ ನಾಟ್ ಒಬೇ ದಿ ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಲಾ. ಓಕೆ, ದಟ್ ಇಸ್ does not obey inverse square law. Next is they are exchange forces. So why it is called as the exchange force? Here what happens? Protons and neutrons, here protons and neutrons are interconverted by exchanging some particles. They are called as what? Mesons anta ಹೇಳ್ತೀವಿ. So here just you remember, ಇದನ್ನೇ ನಾವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಅಂತ ಯಾವಾಗ ಕೇಳಲ್ಲ. ಇಲ್ಲೇನಾಗತ್ತೆ ಅಂತಂದ್ರೆ ಪ್ರೋಟಾನ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ ಮಧ್ಯದಲ್ಲಿ ಹಿಯರ್ ಇಂಟರ್ ಕನ್ವರ್ಟೆಡ್ ಬೈ ಎಕ್ಸ್ಚೇಂಜ್ ಆಫ್ ಸಮ್ ಪಾರ್ಟಿಕಲ್ಸ್. ಇದ್ರ ಮಧ್ಯದಲ್ಲಿ ಕೆಲವೊಂದು ಪಾರ್ಟಿಕಲ್ಸ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗಿ those are called as what? Mesons ಅಂತ ಹೇಳ್ತೀವಿ. ಆ ನೇಚರ್ ಇರೋದ್ರಿಂದ ಪ್ರೋಟಾನ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ ಮಧ್ಯದಲ್ಲಿ ಅದಕ್ಕೆ ಎಕ್ಸ್ಚೇಂಜ್ ಫೋರ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ದೇ ವಿಲ್ ನಾಟ್ ಆಸ್ಕ್ ಯು ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ದೀಸ್ ಆಲ್ ಫೋರ್ಸಸ್. ಅಂದ್ರೆ ಇದೇನೋ ಪ್ರಾಪರ್ಟೀಸ್ ಬರ್ದಿದೀವಿ, ಇದೇನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಕೇಳಲ್ಲ. ಜಸ್ಟ್ ಫಾರ್ ಯುವರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ಲೇನಿಂಗ್ ಯು. ದ ಲಾಸ್ಟ್ ಒನ್ ಇಸ್ that is spin dependent. So here the spin dependent means what happens here? Nuclear force between the two nucleons have parallel spin. So idralli eniratte anta andre, whatever the spin is there between the nuclear forces, it is a parallel spin. So the parallel spin, you can represent it in this way. Okay, I'll just change the color. The parallel spin, the nucleons, the nuclear forces between the nucleons will be a parallel spin. This is how you can represent that. Is stronger than the force between the two nucleons having the anti-parallel spin. So illenide, the force between the parallel spin is stronger than the force between the anti-parallel spin. These are anti-parallel spin representation. These are parallel spin representation. So here nuclear force between the two nucleons having parallel spin is stronger than the force between the two nucleons having the anti-parallel spin. So therefore it is called as what? Spin dependent. Andre ad arrangement parallel spin alli idya athwa anti-parallel spin alli represent ಮಾಡ್ತಾ ಇದೆಯಾ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. Okay, the arrangement matters here. So these are the properties regarding the nuclear forces. So if you have any doubt in all the 9 properties, any point if you want me to explain once again, please ask. Strongly attractive force, strongest force in the nature, short range force, it is charge independent, it is a non-central force, saturated force, does not obey inverse square law. It is called as the exchange force. It is spin dependent. So you can just note down what all points in explanation part, you can note down that, because in the notes I am not giving you the explanation of these all characteristics. Only the 9 characteristics will be there in the notes. Okay, so ಯಾವ್ದಾದ್ರು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಲ್ಲ ಅಂತ ಅನ್ಸಿದ್ರೆ ನೀವು ಆ ಪಾಯಿಂಟ್ ಅನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಬರ್ಕೊಳ್ಳಿ. Just now I have explained. If you want me to repeat anyone, you can. Yes, after completion, please tell in the chat box. We will go for the next point. Okay. Does not obey. Okay. Yes, I'll explain. Here it is does not obeying the inverse square law. Yes. So here I said it does not obey the inverse square law means here if you consider the proton and the neutron, whatever the force between them, suppose if it is F, so the force between them is inverse square law andre ಏನು the force between them obeys, it is inversely proportional to square of the distance between the bodies. So this is called as what? Inverse square law. But nuclear force is not obeying that. ಅಂದ್ರೆ ಫೋರ್ಸ್ ಮತ್ತೆ ಡಿಸ್ಟೆನ್ಸ್ ಇಲ್ಲಿ ಏನು ಸಂಬಂಧ ಇಲ್ಲ. It does not obey the inverse square law, or it is not obeying this case, that is F is inversely proportional to square of the distance. So the nuclear force is not obeying this condition. Okay, so this is regarding the inverse square law. Regarding exchange forces, here what happens, that is the protons ಮತ್ತೆ neutrons ಮಧ್ಯದಲ್ಲಿ ಕೆಲವೊಂದು particles exchange ಆಗುತ್ತೆ. There will be some exchange of the particles, and which is giving you out the new particle that is called as the mesons. It is giving out the mesons. Within the nucleus, a proton do not remain permanently as the proton, and a neutron does not remain as permanently as the neutron. So adra madhyadalli there will be continuous exchange of the some of the particles, which is giving out the mesons anta ಹೇಳ್ತಾರೆ. That is called as exchange force. Okay, so explanation part is not that important, just so 9 properties you remember. Yes, next point hi hogana. Yes, see the next point here, students. That is next we are discussing about the mass defect. So what do you mean by mass defect? See here, the difference between the rest mass of the nucleus and the sum of the rest masses of its constituent nucleons is called as what? It's mass defect. Okay, so what is the meaning of this statement? Here what happens if you calculate the constituents of the nucleus masses. So what are the constituents of the nucleus? That is, the nucleus is consist of what? Now continuously ಹೇಳ್ತಾ ಇದ್ದೀವಿ, the nucleus consists of protons and the neutrons. So ಇದು ಎರಡುದ್ರದ್ದು mass ನೀವು calculate ಮಾಡಿದ್ರೆ, remember here students, protons are having mass, these are having charge also. Neutrons are having only mass, illi charge iralla, they are neutral in nature. Okay, so just that point you remember. So what we were discussing, that is if you consider the proton and the neutron, here what happens, proton ಮತ್ತೆ neutron ಇದು ಎರಡುದ್ರದ್ದು ನೀವು mass ಏನಾದ್ರು calculate ಮಾಡಿದ್ರೆ, so mass of the proton I'll take it as mp, the mass of the neutron I'll take it as mn. So these are the constituents ಆಯ್ತಾ. So the ಎರಡು constituents mass ಮತ್ತೆ mass of the nucleus, ಇದು nucleus ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಇದ್ರ mass ಏನಾದ್ರು ನೀವು calculate ಮಾಡಿದ್ರೆ nucleus, there will be a difference. Yes, so if you calculate the mass of the nucleus and mass of the constituent particles of the nucleus, so constituent particles andre mass of the proton plus mass of the neutron, ಇದೆರಡನ್ನ calculate ಮಾಡಿದ್ರೆ ಎರಡು equal ಬರಲ್ಲ, there will be some difference in the masses. ಸೊ ಆ ಡಿಫ್ರೆನ್ಸ್ ಏನಂತ ಹೇಳ್ತಾರೆ, ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದಿ ಮಾಸ್ ಡಿಫೆಕ್ಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಹಿಯರ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂತಂದ್ರೇನೆ ಏನಂತ ಹೇಳಿದ್ವಿ ಇಷ್ಟರವರೆಗೆ, ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಸ್ ಕನ್ಸಿಸ್ಟಿಂಗ್ ಆಫ್ ದ ಪ್ರೋಟಾನ್ಸ್ ಅಂಡ್ ದ ನ್ಯೂಟ್ರಾನ್ಸ್. ಹಾಗಾಗಿ ನಿಮ್ಗೆ ಏನ್ ಅನ್ಸುತ್ತೆ, ದ ಮಾಸ್ ಆಫ್ ದ ಪ್ರೋಟಾನ್ ಪ್ಲಸ್ ಮಾಸ್ ಆಫ್ ದ ನ್ಯೂಟ್ರಾನ್ ಇಸ್ ಗಿವಿಂಗ್ ಔಟ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್. ನೋ, that is not right. So what they are saying here, there is some mass defect. ಹಾಗಾದ್ರೆ ಮಾಸ್ ಡಿಫೆಕ್ಟ್ ಏನಂದ್ರೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ನೀವು ಆಕ್ಚುಯಲ್ ಮಾಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ, ಮತ್ತೆ ಮಾಸ್ ಆಫ್ ದ ಪ್ರೋಟಾನ್ ಪ್ಲಸ್ ಮಾಸ್ ಆಫ್ ದ ನ್ಯೂಟ್ರಾನ್ ಏನಾದ್ರು ಆಡ್ ಮಾಡಿದ್ರೆ, we are not getting the values same. There will be some difference in the mass of the actual mass of the nucleus and the mass of the constituent particles of the nucleus. That is called as what? Mass defect. Understood what is mass defect here? See, the difference between the rest mass of the nucleus and the sum of the rest masses of the constituents of the nucleons is called as its mass defect. Yes, definition is clear to everyone. What is mass defect? Yes, is it clear? Mass defect. Yes. So here, how to calculate the mass defect? Okay, ನಮ್ಗೆ ಈಗ ಏನ್ ಗೊತ್ತಾಯ್ತು, there is a mass difference. ಹಾಗಾದ್ರೆ how to calculate that? The mass defect is denoted by the letter delta m. So this mass defect is given by delta m is equal to z into mp. ಇದು ಪ್ರೋಟಾನಿಗೆ ಆಯ್ತು, ಪ್ಲಸ್ a minus z. a minus z ಏನ್ ಬರುತ್ತೆ, number of neutrons into mass of the neutrons minus capital M. This is the very, very important formula which you need to remember. How to calculate the mass defect here? Mass defect is given by, that is Z is the atomic number. MP, mass of the protons, plus A minus Zn kodatte, it is giving you the number of neutrons. Mn is what? Mass of the neutron. Capital M is the mass of the nucleus. Suppose if you want, we will write here the terms. Delta M is denoted for the mass defect. Z is the number of proton anta heli, athwa that is, it is also called as the atomic number or number of protons, or it is called as the number of protons. Next, MP. What is MP? Mass of the proton. MP is the mass of the proton. Next, A minus Z. A minus Z ಏನ್ ಕೊಡುತ್ತೆ, ನಿನ್ನೆ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. A minus Z is giving you the number of neutrons. It is giving you the number of neutrons. What is Mn? Mn is the mass of the neutron. It is giving you the mass of the neutron. And the capital M is the mass of the nucleus. Yes, it is called as the mass of the nucleus. Correct? So if you use this formula, what you are getting? You are getting the mass defect. So here, the mass defect is nothing but it is the difference in the mass of the nucleus with its constituents of the nucleons. That difference is called as the mass defect. You can use this formula, Z into Mp plus A minus Z into Mn minus capital M. Okay, so this is regarding the mass defect. The next definition in this chapter is, that is the binding energy. So what do you mean by binding energy? Let us see. Yes, the binding energy is defined as, it is the energy required to break a nucleus into its constituents, protons and neutrons, to separate them such a large distance that they may not attract with each other. That energy is called as what? Binding energy anta ಹೇಳ್ತಾರೆ. Here we can define the binding energy in two forms. So it is also defined as, it is the minimum energy required to break. So in short, ನೀವು ಹೇಳ್ಬೇಕು ಅಂತ ಅಂದ್ರೆ, it is some minimum energy. So the mass defect is defined as, it is the minimum energy required. It is the minimum energy required to break the nucleus. It is the minimum energy required to break the nucleus into its constituents particles. Into its constituent particles is called as what? That is mass defect. So idanne ಸ್ವಲ್ಪ explain ಜಾಸ್ತಿ ಮಾಡ್ಬೇಕಂದ್ರೆ ನೀವೇನಂತ ಹೇಳ್ಬೋದು ಇಲ್ಲಿ, it is the energy required to break a nucleus into its constituents. ಸೊ ಕನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಅಂದ್ರೆ ಏನು, ನ್ಯೂಕ್ಲಿಯಸ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ವಿ, ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಸ್ ಕನ್ಸಿಸ್ಟಿಂಗ್ ಆಫ್ ಪ್ರೋಟಾನ್ಸ್ ಅಂಡ್ ದ ನ್ಯೂಟ್ರಾನ್ಸ್. ಸೊ ಇದು ಬೈಂಡಿಂಗ್ ಎನರ್ಜಿ ಏನ್ ಹೇಳುತ್ತೆ ಅಂತ ಅಂದ್ರೆ, ಇಟ್ ಇಸ್ ದ ಎನರ್ಜಿ, ಇಟ್ ಇಸ್ ಎ ಮಿನಿಮಮ್ ಎನರ್ಜಿ ವಿಚ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್ ಟು ಬ್ರೇಕ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ to its constituents particles. That minimum energy is called as what? Binding energy. ಆ ಎನರ್ಜಿಯನ್ನ ಏನಂತ ಹೇಳ್ತಾರೆ? It is called as the binding energy. Here this binding energy we can write it with the formula. The binding energy is given by the formula, that is delta E is equal to delta M into C square. So this is nothing but Einstein's energy mass energy relation. So that is E is equal to delta M into C square, where C is the velocity of light in the vacuum, value constant is 3 into 10 to the power of 8 meter per second. What is delta M here, students? The delta M is nothing but it is the mass defect. The delta M is nothing but it is the mass defect. Okay, so delta E is the binding energy anta helbodu. Okay, so suppose if you want to calculate the binding energy by substituting mass defect, our formula ನಾವು ಏನಂತ ಬರಿಬಹುದು ಇಲ್ಲಿ? Because we know that the binding energy is equal to mass defect formula ಈಗಷ್ಟೇ ನೋಡಿದ್ವಿ, it is Z into MP plus A minus Z into Mn minus capital M, this is your delta M value, into C square, into C square. So that is delta M into C square, correct? So this is the regarding the binding energy. So idralle mattond definition barutte, that is binding energy per nucleon anta. Okay, the binding energy per nucleon, in some of the textbook they define it as the binding energy per nucleon is also called as specific binding energy. Okay, don't get confused with binding energy and the specific binding energy. So these are slightly, there is a difference between both of these terms. Binding energy andre ನಾವು ಈಗಷ್ಟೇ ಹೇಳಿದ್ವಿ, it is the energy required to break the nucleus into its constituents particles is called as the binding energy. ಮತ್ತೆ ಇಲ್ಲಿ what is that? That is binding energy per nucleon ಅಂತ ಏನ್ ಹೇಳ್ತೀವಿ, that is called as specific binding energy. Okay, so what about the binding energy per nucleon? How you can define? As the definition or the heading is saying, binding energy per nucleon anta andre the binding energy divided by mass number. The binding energy divided by mass number is called as what? Binding energy per nucleon. So this is the binding energy divided by mass number is denoted by A. So binding energy per nucleon is given by, it is binding energy per nucleon, or it is divided by mass number. So mass number andre ನೀವು ಯಾವ್ದು ಎಲಿಮೆಂಟ್ ಅನ್ನ represent ಮಾಡ್ತೀರಾ, mass number you can get it here. So suppose if you have helium 24, so ಇಲ್ಲಿ helium binding energy per nucleon find out ಮಾಡಿ ಅಂತ ಅಂದ್ರೆ delta E first ನೀವು calculate ಮಾಡಿ by using this above formula. By using this above formula, divided by what you are going to do, divided by, you do it by 4. So divided by 4 if you are doing, it is nothing but the binding energy per nucleon. Okay, so this is binding energy per nucleon. See, so here we have defined 3 definitions, students. One is the mass defect. Mass defect is the difference in the masses. Binding energy to break the nucleus into its constituents particles is called as the binding energy. Binding energy per nucleon anta andre binding energy divided by mass number ಮಾಡ್ತಾರೆ. Yes, see, any doubt is there in the terms? Okay. Yes. So mass defect, binding energy per nucleon. Okay. So now we can go for the next point. So here you can see, students, that is the binding energy is given by ZMP plus A minus Z into Mn minus M, that is capital M is the mass of the nucleus, into C square. So here it is binding energy, and here we have the binding energy per nucleon. So here you can see the both the formulas. Okay. So here you just see one more point. There is the mass energy equivalence. So what is mass energy equivalence? Einstein's proved that it is necessary to treat the mass as another form of energy, and he gives this mass energy equivalence. So the mass energy equivalence is given by what? E is equal to mc square. It is also called as Einstein's equation. Okay, Einstein's mass energy relation. E is energy, m is mass, c is the velocity of light in the vacuum, its value is constant. Okay, so with respect to this formula, we can calculate the energy. So here this formula we are using it to calculate the binding energy. Yes, is it clear? Okay, so the next point regarding this chapter, we are defining about the nuclear fission and the fusion reaction, which we will continue tomorrow, students. Okay, so nuclear fission and fusion process we will discuss tomorrow. So tomorrow this lesson will get over. Okay, so we will meet in the next class. Thank you.